Assalamu alaikum everyone. Today we will understand about hidden Markov model. Hidden Markov model is different from the discrete Markov model. In discrete Markov model we know about the states, but in hidden Markov model actually the states are hidden, the states are not visible, and there are some observations on the basis of which we try to predict about the states. So let's take an example. There is a city in which there are three types of weathers. Sometimes it is sunny, sometimes it is rainy, and sometimes it is cloudy. So there is a person who is coming to office. One day he is wearing shorts, some days he is putting on a coat, and some days he is carrying an umbrella. So we only observe his clothing sense, and on the basis of this observation, we are predicting about the states of weather in his city. So these states of weathers are actually, hidden states, and these observations are the one which we are actually observing. So let's I have plotted this hidden model already. So for this hidden model we have got some transition probabilities and we have got some emission probabilities. The transition probabilities are actually the weights which are relating the states with one another, and emission probabilities are actually relating these states with the outputs, or in other sense we can call them observations. So first of all we will write down the number of states. Right now we have got 3 states. Then after writing the states we write down the observations. So right now we have got 3 observations. The start probabilities are given to us in the question. The start probability is 0.75, 0.2 and 0.05. These are actually the start probabilities values. So now let's write down the transition matrix. What is a transition matrix? Transition matrix is simply writing down all the weights which were given on the lines joining the transition states. So the probability, when you write a transition matrix, you simply write down the states on top and on this side, and you start reading from this line first. So that will not be confusing anymore. So let's start reading. What is the probability that it is sunny? Given that it was sunny before, it is 0.8. What is the probability that it is going to be rainy? Given that it was sunny before, it is 0.15. You can correlate it from here. It is 0.15. So what is the probability that it is cloudy, given that it was sunny before? So it is 0.05. You can again correlate it from here. Yes, 0.05, right? Similarly, what is the probability of being sunny if it was rainy before? What is the probability of rainy if it was rainy before? You can see it is 0.6, and it is also given as 0.6. What is the probability that it is cloudy given that it was rainy? It is 0.02. You can see it from the diagram. It is 0.02. Similarly, for the last row we write it in the same manner. So after writing the transition matrix, we can go on to the emission matrix. So emission matrix is basically relating the output states with your hidden states. So we write down all the emission states or the observations, that the person is wearing shorts, coat or umbrella, and on this side we are writing the hidden states. So hidden states related with shorts is giving you 0.3, 0.6, 0.3, 0.1, 0.05, 0.30, 0.65, 0.1, 0.5 and 0.5. You can even relate it from the diagram. You can see that, let's assume I am considering sunny. So for sunny, the person was wearing shorts was 0.6. For sunny, the person wearing shorts was 0.6. Similarly for coat, the person this probability is 0.3, and then it is 0.1. For cloudy, it is 0.1, 0.5 and 0.5. So actually this is not the difficult part. This transition and emission matrix is a simpler part. So when we are doing this hidden Markov model, we can have a lot number of possibilities of joining these. There can be so many number of sequences. For example, see, if we have got 3 hidden states and we have got 3 observations. So the number of possible combinations that can be made is 3 raised to n raised to the power o, which is actually 3 raised to the power 3 here. So there can be 27 possible combinations. By combinations, I mean to say that there can be a combination that the day is sunny, then again the day is sunny, and then again the day is sunny. So whether the person is wearing a coat, he's wearing a coat, he's wearing a coat. So this can be a sequence of joining the hidden states with the observations. Similarly, there can be another sequence. Assume we take this sequence that one day the weather was sunny, the person came to office and he was wearing a coat. The other day the weather was rainy, the person decided that okay, let's wear a coat again. And the third day the weather was cloudy and the person decided, all right, let's carry an umbrella. By the way, that was quite a not such a good choice anyways. So there can be so many number of sequences or combinations of days and of the clothing choices that he is going to make. So in this state where we have 3 hidden states and 3 observations, there can be 27 possible combinations. First thing that we need to understand is this thing. Okay, now let's assume that we are going to work on a single sequence, and in the exam we are asked to solve a single sequence. Maybe we have been asked to find out that what is the probability that in the city where that person was living, in that city the weather was sunny, and then the other day it was rainy, and then it was cloudy, and he was carrying a coat, and then an umbrella. All right, so you have to find out that probability. So first you have to understand the concept of joint probability. Whenever we have a joint probability between 2 variables, we open it up in the form of a conditional probability multiplied with the second variable. So this is an important equation that you need to understand. So if we have to write a joint probability between coat and sunny, it will be written like coat such that it was sunny, or given that the day was sunny, multiplied with sunny. This thing that I have written over here, it is just for this single string. The person is wearing a coat and sunny, it is just written for this first string. So now let's consider this complete case. So when I consider this complete case, I will write that the probability of person wearing coat, again he is wearing coat, again he is putting on an umbrella, and the weather over there is sunny, the weather is rainy, and the weather is cloudy. So when I have to find this probability, I have to use the joint probability equations. So for the first term, it is written as probability of coat. We are linking it, probability of coat such that the day is sunny. Then we write that the probability of coat such that the day is rainy. And then we write the probability of umbrella such that the day is cloudy. These 3 terms are actually written with the conditional probability. Then we write that probability that the day is sunny. This is the first day, this is the present state. So by the Markov property, when we talk about the present state, we are actually given in the question that it is basically the first day is sunny. So we simply write it as an independent start probability. Then for the second thing, we write that probability that the day is now rainy, given that it was sunny before, and then we write that probability that the day is cloudy, given that it was sunny before. So we are actually doing that linking, first of all linking this thing coat with sunny, linking coat with rainy, and linking umbrella with cloudy. And then we are writing this probability and linking this thing with this, that probability that the day is rainy given that it was sunny before, and linking this with this, that probability that the day is cloudy given that it was sunny before. So we have got these terms. We will now see that the first 3 terms will come from the emission matrix and the last 3 terms will come from the transition matrix. So now let's see the matrices as well. So for this first term, probability of wearing a coat such that it is sunny, we take it from here and it comes out to be 0.3. So we write 0.3 over here. Then this probability of wearing the coat such that it is rainy, it again comes from this transition matrix and we get the answer 0.30. So we put 0.30 over here. Then this term, that probability of carrying an umbrella such that it is cloudy, it is coming out 0.5, so we put 0.5 over here. So first three terms have came from the this emission matrix. For the next three terms, this first term is actually the start probability. We were given in the question the start probability is 0.75, so we simply write down the start probability as 0.75, and afterwards the probability of rainy such that it was sunny before. This 0.15 term has came from here because probability of rainy such that it was sunny before is 0.15, and this next term 0.02, it is coming from probability that it is cloudy given that it was rainy before. Probability that it was cloudy given that it was rainy before, it is 0.02. So when we multiply all six terms, we get an answer. Well, I have not calculated the answer, but you can calculate it. And you have to keep this one thing in mind, that this answer is just one answer. If we have to find all the possible cases that maybe the weather in that city is changing in a different pattern, maybe after sunny the weather is getting cloudy, after cloudy the weather is getting sunny, so there can be 27 combinations. So we have to, in this way we have to find the 27 probabilities. For the 27 combinations, then we will take the max out of all those probabilities, which will be actually the answer, that this is the highest probability out of all the possible combinations that can occur that the person is carrying or wearing this type of stuff and the weather over in his city is this. So that will be the maximum probability. But if you are simply given a sequence, that this is the sequence of events, you don't have to find the maximum possible case. You are just given with a sequence of event and you have to find for this specific sequence, then you just have to find out this one case. And if you are not given a sequence, if you are asked to find all the possible combinations and then the maximum out of those combinations, then you have to find out these 27 probabilities. In this case, where you are given three hidden states and three observations. If maybe there were like 4 observations, then it would have been 3 raised to the power 4, so on. So I hope you understand. If you have any questions, you can ask me in the comments, and do like the video, do appreciate it if you like it. Thank you very much. Allah Hafiz.